This class we worked out three problems. First problem is a star connected balanced load of 25 kVA. We are going to measure the power. First question is determine the wattmeter reading if the power factor of the load is number 1 unity, number 2 0.866 lagging, number 3 0.5 leading, and number 4 90 degrees lagging. So this is the diagram. We are connecting two wattmeters. This is W1, this is W2, this is RYB. First step, we have to calculate the total power consumed by the load. That is total active power consumed by the load. That is kVA into cos theta. kVA is given 25 into cos theta. W1 plus W2 is equal to 25 cos theta. You know the formula, tan theta is equal to root 3 into W2 minus W1 divided by W1 plus W2. We know W1 plus W2, we have to find W2 minus W1. Tan theta is equal to sin theta by cos theta into 25 into cross multiply, 25 into cos theta, that is equal to root 3 into W2 minus W1. W2 minus W1 is equal to 25 by root 3 into sin theta, that is equal to 14.43 sin theta. First case, unity power factor. The load is resistive load. W1 plus W2 is equal to 25 cos 0, that is equal to 25 kilowatts. Wattmeter 1 reads 12.5 kilowatts. Wattmeter 2 reads 12.5 kilowatts. When the load is resistive, both wattmeter readings are equal, and this is also positive, this is also positive. Okay. Case 2. 0.866 lagging. Theta is equal to 30 degrees. Sin 30 is equal to 0.5. First we calculate W1 plus W2. W1 plus W2 is equal to 25 into cos theta. Cos theta is given 0.866, that is equal to 21.65 kilowatts. W2 minus W1 is equal to 14.43 into sin theta. Sin theta is 0.5, that is equal to 7.27 kilowatts. Simplify it. W1 reads 7.19 kilowatts. W2 reads 14.46 kilowatts. Okay. Both are positive. The values are different because the power factor is 0.866, that is the lagging, theta is equal to 30 degrees. Case 3, 0.5 leading. 0.5 leading means theta is equal to 60 degrees, theta is equal to minus 60 degrees. Leading. W1 plus W2 is equal to 25 into cos minus 60. W1 plus W2 is equal to 12.5 kilowatts. W2 minus W1 is equal to 14.43 into cos sin 60. That is equal to 12.5 kilowatts. Simplify it. This is W1 plus W2 is equal to 12.5. W2 minus W1 is equal to 12.5 kilowatts. W1 plus W2. So W1 must be 0. This wattmeter reads 0 value. This wattmeter reads 12.5 kilowatts. So when the power factor is 0.5 leading, or theta is equal to 60 degree, one wattmeter reads 0, another wattmeter reads the 12.5 kilowatts. That is the total power. Case 4. 90 degrees lagging. Theta is equal to 90 degrees. Cos 90 is equal to 0. W1 plus W2 is equal to 25 into cos 90, that is equal to 0. W2 minus W1 is equal to 14.43 into sin 8. Sin 8 is equal to 1, that is equal to 14.43 kilowatts. So simplify it. W1 is equal to minus 7.215 kilowatts. W2 is equal to 7.215 kilowatts. Why we put minus sign? For the first case, the W1 is negative value. We have to interchange the M and L. That value should be considered as minus. Therefore, W1 is equal to minus 7.215 kilowatts. W2 is equal to 7.215 kilowatts. Second problem. A three-phase 400 volt load has a power factor of 0.4. Two wattmeters connected to measure the power consumed show the input power to be 30 kilowatts. Find the readings of individual wattmeters. That is the question. So W1 plus W2 is equal to 30 kilowatts. We know the formula. Tan theta is equal to root 3 into W2 minus W1 divided by W1 plus W2. We have calculated W1 plus W2 is equal to 30. We have to calculate W2 minus W1. Theta value is given 0.4, that is cos theta is 0.4, theta is equal to 66.6 degrees. Tan 66.6 degrees is equal to root 3 into W2 minus W1 divided by 30. Here W1 plus W2 is equal to 30. I put 30. Simplify it. You get W2 minus W1 is equal to 40 kilowatts. W1 plus W2 is equal to 30 kilowatts. 2 W2 is equal to 70 kilowatts, W2 is equal to 35 kilowatts. So 35 minus W1 is equal to 40, therefore W1 is equal to minus 5 kilowatts. W1 plus W2 is equal to 30 kilowatts, correct? So W1 is equal to minus 5 kilowatts, W2 is equal to 35 kilowatts. This wattmeter 1 reads negative value. This is because the power factor is less than 0.5. You can check the value. Tan theta is equal to root 3 into 40 by 30. That is equal to 2.31 degrees. Theta is equal to 66.59 degrees. Cos 66.59 is equal to 0.4. This way you have to work out this problem. Third problem. Non-inductive loads of 20, 12 and 8 kilowatts are connected between the neutral and the 3 line terminals of 3-phase 4-wire 400 volt system. So this is the figure. The question is find A line currents, B neutral current, C readings of the 2 wattmeters used for power measurement. The line to line voltage is given 400. Per phase voltage is 400 by root 3, that is equal to 231 angle 0 degrees in volts. VYN is equal to 231 angle 120 degrees in volts. VBN 231 angle minus 120 degree in volts or 240 degrees in volts. Now we can calculate the current IR, IY, IB. The per phase load is given, that is 20 kilowatts, 20 to 10 power 3 by 231 angle 0, that is equal to 86.58 angle 0 degrees in amps. IY is equal to 51.95 angle minus 120 degrees in amps. IB is equal to 34.63 angle 120 degrees in amps. Okay. Second question is we have to find the neutral current. IA plus IB plus IC is equal to 45.81 angle minus 19.11 degrees. IN is equal to minus IA plus IB plus IC. So IN is equal to 45.81. So 180 minus 19.11, that is equal to 160.89 degrees. The non-inductive load power factor is 1. The 2 wattmeter reads the same value and the values are positive. Therefore, W1 plus W2 is equal to 20 plus 12 plus 8, that is equal to 40 by 2, that is equal to 20 kilowatts. W1 reads 20 kilowatts, W2 is equal to 20 kilowatts, W1 plus W2 is equal to 40 kilowatts. This way you have to work out this problem. With this I conclude my lecture. Thanks for listening.